So we are now in mole to gas volume conversion. Molar volume at STP, or standard temperature and pressure, can be used to convert from moles to gas volume and from gas volume to moles. The equality that we'll be using is for every mole of any gas, this is also equivalent to 22.4 liters of that gas. This will be our basis for the conversion, or our conversion factors. STP has different definitions. In IUPAC, the standard temperature and pressure, the values of them are 273.15 kelvins for temperature. It's also equivalent to 0 degrees Celsius and 32 degrees Fahrenheit. And for pressure, we have 10 raised to 5 pascals, or 100 kilopascal, or 1 bar. In NIST, the standard temperature and pressure is 20 degrees Celsius and 1 atmosphere, or 1 atm. For the purposes of this discussion, we're only sticking with the IUPAC definition of STP. Let's try this value in an actual problem. Many metals react with acids to produce hydrogen gas. What if a certain reaction produces 86.5 liters of hydrogen gas at STP? So how many moles of hydrogen were produced? So for the solution for this problem, all you have to do is list the known and unknown quantities and plan the problem. The known quantities are 86.5 liters of hydrogen gas, and our basis for conversion, 1 mole is equal to 22.4 liters at STP. The unknown value is the number of moles for hydrogen gas. Next, we're going to calculate, and we'll apply the conversion factor at STP to convert from liters to moles. When solving for the correct answer, the way is just like what we did in mole-to-mole conversion or in our previous conversion practices or problems. So we just simply multiply the given information to the conversion factor. This time, our conversion factor is the value of moles and liters of gas at STP. So see to it that the units are cancelled. And since the given is liters, the denominator of our conversion factor should also be in liters. So 86.5 times 1 divided by 22.4, this is equivalent to 3.86 moles of hydrogen gas. Therefore, the number of moles of hydrogen gas produced if a certain reaction produces 86.5 liters is 3.86. Let's try to solve for these problems. I want you to solve for these problems in your notes. A container contains 45.2 liters of nitrogen gas at STP. How many moles of nitrogen gas are in the container? What volume does 4.96 moles of oxygen gas occupy at STP? The next part of stoichiometry is conversion of moles to number of particles. In our prelims, we already know that 1 mole of every substance is equivalent to Avogadro's number, or 6.022 times 10 raised to 23, number of atoms, number of molecules, or number of formula unit. A conversion can be made easily using this relationship. Example, the element carbon exists in two primary forms, graphite and diamond. How many moles of carbon atoms is 4.72 times 10 raised to 24 number of carbon? Again, we have to list the known and unknown quantities and plan the problem. Basing on the problem, it is stated that there are 4.72 times 10 raised to 24 atoms of carbon, and our basis for conversion is the Avogadro's number. 1 mole is always equivalent to 6.022 times 10 raised to 23 atoms. The unknown is a number of moles for carbon. The last step is we have to apply that conversion factor to convert from atoms to molecules. Remember, you have to write in the denominator the unit that you want to cancel. For example, we need to cancel the number or the unit for the number of atoms. And that's why Avogadro's number 6.022 times 10 raised to 23 number of atoms should be written in the denominator. So we need to multiply and then divide. 4.72 times 10 raised to 24 times 1 divided by Avogadro's number is 7.84 moles of carbon. To summarize, when you want to convert mass to molecules, we need to divide the substance mass by its molar mass. If you want to convert it back to mass, we need to multiply the number of moles or molecules to its molar mass. If in the right side of this picture, if you want to convert most of atoms into grams of atoms, we simply multiply it to its atomic mass. Or if you want to convert it back from mass of atoms into moles or moles of atoms, we need to divide by its atomic mass. Remember, when we deal with atoms and molecules, Avogadro's number is the basis for conversion. To summarize, the mole connects atoms, mass, and volume in chemistry. Balance equations show the exact relationships between reactants and products. We can convert between moles, mass, and particles to understand chemical quantities. Mole ratios guide us in predicting how much of each substance is needed or produced. And lastly, stoichiometry helps us see how chemical reactions are measured and quantified in the real world. In this part, we have two problems here, and I want you to submit this next meeting.